morning to all of you. I am Priyanka Sharma, Assistant Professor, EC Department. I am going to present my video lecture on Fundamentals of Electronics Engineering, and the subject code is BC 101. In this lecture, we will going to cover about the important topic of the application of diode, that is clippers. So in this video lecture, we will going to familiarize about the application of diode, that is clippers, how it will going to operate, and what are the different type of clippers. So first of all, this is my content of video lecture. In the clippers, we will going to study about series clipper and parallel clipper. So before going into the deep discussion, first we will going to familiar about what is clipper. What is clipper? Clipper is a device which can clip off some portion of the signal. So diode clipper can be defined as the network that employ diodes to clip away the portion of an input signal without distorting the remaining part of the applied waveform. So we can use this clipper in many communication systems for clipping of the signal. So this clipping will not going to distort any remaining part of the waveform. So we can see here the basic circuit of the diode clipper. This is the basic circuit. We can see here this basic circuit consists of one single diode, and it consists of one resistor which is in series with the diode. And here at the input side, we can give the input current which is defined by Vi, and the output is taken across the resistor. So here if we are giving a simple sinusoidal input, corresponding to this input, we will get the clipped output. So whatever the clipping we require, either we can clip the diode from positive portion or we can clip the diode from negative portion. We can make different combinations of network. So the first we should know first about what is clipping. So we can have different waveforms, we can have different clipping options. If suppose we have a square wave, then we can clip either negative cycle. So this can be called as negative clipper. If we have a triangular signal, in this also we have seen here negative cycle is missing. So we can say here the negative cycle is clipped. So these clipping options can be generated by forming different networks with the help of diode circuits. So we can see the different diode networks which can clip the circuit, clip the signal at different portions. So if we start with first, if I had told you about the diode clippers. So first of all, diode clippers can be categorized as series clipper and parallel clipper. Series clipper and parallel clipper. In series clipper, diode circuits, diode is connected in series. So we have the diode which is connected with the input in series, and the output is taken across the resistor. And in this we can also see that we can clip the signal either from positive side or from the negative side. So this series clipper can also be called as positive clipper, and we can also have negative clipper. Apart from this, we can also add a different type of clipper which is called as biased clipper. Biased clipper, which can be series clipper also, which can be parallel clipper also. In biased clipper, we can clip the signal either from any portion of the signal. That means we can clip the either from this side or at this level, at this level. Different levels can be decided by biased clipper. So we have these different combinations of clippers. Now if we start with the basic diode series clipper, so in basic diode series clipper, we have series clipper, we have the basic circuit. If we will going to make first negative clipper. For negative clipper, the basic circuit is presented as, this is the diode I had connected here, one resistor is connected here, and let us say we are taking the input signal as sinusoidal input. So this is the sinusoidal input Vi, and we have the output we will take here at the output side. So now if we do the analysis of this negative clipper, we will start with first positive cycle. So for positive cycle, we will going to analyze the circuit. For positive cycle, this end will become positive and this end will become negative, and the diode will be, this diode will be forward biased. So for positive cycle, diode is forward biased, and in forward biased condition, we all know that diode is assumed to be act as a short circuit. So it is acting as a short path if we consider ideal diode. So for ideal diode, it is acting as a short path. Now the equivalent circuit we will obtain here is, this is Vi. We will consider short path for forward bias condition, and we will get the output at the resistor. So this output, if we will going to calculate, this is same as input. So we can say V out is exactly equals to Vi. So the output waveform is same as input waveform for the positive cycle. Now if we see the negative cycle, let us take the negative cycle. For negative cycle, this end will become, now this end will become negative and this end will become now positive. So this end negative is connected to positive of diode. So this diode will become reverse bias. And we know that in reverse bias, there will be no current flows through the diode and it is acted as open circuit. So we can say here, if the diode will be reverse biased, and in reverse biased condition, it is acting as open circuit. So we can draw the equivalent circuit and diode will become open circuit in reverse bias for negative cycle. This is Vi. Now if we want to take the output, this output will be equals to 0 because the current flowing through the circuit is 0. So we can say here, there will be no output in the negative cycle. So this negative cycle is clipped off here. We can say it is said to say here कि negative cycle is clipped off. Negative cycle is clipped off. So that's why it is called as, negative clipper. That's why it is called as negative clipper. Similarly, we can also make here positive clipper, positive series clipper. For positive series clipper, we have the circuit in the same way, only the diode direction will be reversed. So this arrangement will give you the positive clipper circuit. Again, the analysis can be done in the same way as we had done it for the negative clipper. So for positive clipper, again if I take the positive cycle first, if I am taking the positive cycle first, for positive cycle, in this case diode will be firstly reverse biased. So in this case diode will be reverse biased and it is acted as open circuit. So the circuit will be look like this. So for positive cycle, there will be no current flowing through the diode and the output obtained here will be 0. So we can say here, there will be no cycle coming out here for the positive cycle. Now for the negative cycle, if we look at for the negative cycle, for negative cycle, if we consider here we can see the diode will be forward bias because negative is connected to the negative end of the diode. So for negative cycle, this diode will be diode is forward bias and it is acting as a short circuit. So the circuit will be look like this, short path and resistor will be here. For negative cycle, this is Vi input, we will get output is equals to minus Vi. That means we will obtain the negative cycle as it is. So for negative cycle, for positive cycle, no signal will be there. For negative cycle, the signal will be obtained. So we can say here, the positive cycle will be clipped off. Positive cycle is clipped off. So this is the basic of clipper. So how we're going to analyze the circuit for the basic circuit. So this is the basic analysis of series diode clipper. Now the ये दिख रहा है, ये वाला माइक का जो ट्रांसमीटर है, अच्छा ये हाँ. So either we are going to clip the positive cycle complete or we had going to negative cycle completely. So now if we're going to see the next level, if you want to clip the circuit, clip the signal either from any reference level, either from this side, we can have to use the biased series clipper. So biased series clipper circuit we're going to see here. So if we talk about the biased series clipper circuit, in this we have to add one DC level here. So adding a DC source in series with the clipping diode changes the forward bias of the diode. So initially whatever input voltage we are giving, that whole voltage is appearing across the a diode, but in case of bias clipper, the DC source which will going to add, that will going to add up or subtracted from the input voltage, so that the effective voltage across the diode will be changed, and accordingly diode will be forward biased or reverse biased. So now next we are going to see or analyze the bias clipper circuit. So if we take the example of this bias clipper circuit, or we are going to analyze the bias clipper circuit, we will start with bias clipper circuit. So I am taking one example. This is the bias clipper circuit. A diode is connected in series with the battery, and I am giving the input here in the square waveform. So if square waveform input is given here for positive cycle and in negative cycle, we can see here amplitudes are different. So we again have to analyze it in two parts, for positive cycle or negative cycle. So for positive cycle, we have first going to analyze it. So for positive cycle, we have input at this diode circuit 20 volt. Now we are giving 20 volt, this is plus 20 volt. Now for analyzing this type of circuit, we have to calculate the effective voltage before the diode. Let us say this is V1. So if we first going to calculate the V1 by taking the total voltage across this, by using the KVL concept, we have, this is, if I am using the KVL concept, minus to plus, I have minus to plus, I have plus Vi, and minus to plus, this is the DC voltage, again we have 5 volt, and this is V1 I am taking at positive potential, or I am taking this as positive potential, I am taking this as minus V1, so it is equals to 0, or we can say V1 is coming out to be Vi plus 5. So if we want to calculate V1 by analyzing V1 value, we can check whether the diode will be forward bias or reverse bias. So in this situation, we have Vi plus 20 plus 5, the V1 is positive or plus 25 volt. So in this case, this potential is coming at positive potential. So positive potential is connected to positive of diode. That's why this diode will be said to be forward biased, if I am assuming this as a ideal diode. So in this condition, the equivalent circuit will be like this. This is 20 and this is the DC voltage plus 5 volt, and this diode will be forward biased, and after the forward bias the circuit will be completed as this, and the Vout will be coming out to be by calculating it or applying the KVL. So if I am applying the KVL, again the same equation will be there. This whole voltage plus 25 volt is coming at the Vout. So Vout is coming out to be plus 25 volt, sorry, this is plus 25 volt. So now in this case output is coming out to be plus 25 volt. So this is for positive cycle. Now if I am going to analyze it for negative cycle, if I am going to analyze it for negative cycle, the diode will be, if negative cycle is applied, minus 10, this is 10, this battery voltage is here, the equation will be changed. This is the diode. The arrangement of diode I had taken, the positive is taken here, this is positive, and this resistor is connected here. Now if we check again V1 here, this V1 is coming out to be Vi plus 5, but now the Vi here is minus 10 plus 5, it is coming out to be minus 5. That means this V1 is at negative potential. So if negative potential is connected to positive of the diode, then this diode is said to be in reverse bias condition. So in reverse bias condition, this diode will be treated as open circuit, and we know that in open circuit there will be no current flow will take place, and that's why output will be coming out to be 0 volt. So we can see here the complete graph. For half time cycle we will get the output as 25 volt, and for remaining time cycle when the diode will be reverse biased, the output is coming out to be 0. So this is the complete waveform that is obtained after analyzing this bias circuit. So this is how we can going to solve this type of series bias circuit. So this is the series bias circuit. Now next, if we talk about the parallel clipper, this is again same as series clipper circuit, only the arrangement of diode will be changed. In this case diode is taken in shunt, or we can say we will take the output across the diode and resistor is coming into the series part. So that's why it is called as parallel clipper. Again the same definition will be there. The diode in parallel clipper circuit again going to clip off any voltage that forward bias it. So again it can be of two types, positive clipper or negative clipper, and we can also make parallel clipper in bias clipper condition. So one by one we are going to again study here. So if we look into this, again if I am applying the square wave, we can clip the positive cycle, we can clip the negative cycle also. So we can also have in parallel clipper we have again two types of clipper, positive clipper and we have negative clipper. So first we are going to understand the basic concept by analyzing these two circuits. So let us take first positive clipper. In positive clipper circuit, we have the diode arrangement like this. So this is the diode arrangement I had taken. In this again input taken, I had taken the sinusoidal input, that is Vi, and this is the output. So again I am going to analyze this positive clipper for positive cycle as well as for negative cycle. So for positive cycle, first if I am going to analyze it for positive cycle, first it is analyzed for positive cycle. This end will become positive, this end will become negative. So by taking this end, this is also become the positive potential and this is also at negative potential. So we can say diode is connected to positive potential or positive is connected to P type of diode. So this diode is said to be in forward bias condition. Diode is said to be in forward biased. So if it is forward bias, this is acting as a short path. This is acting as diode is treated as short path, or the equivalent circuit will be look like this. This is the short path and this is the input I had given. Now what will be the output? The concept will be is this: I have to take the output across diode. Even if the current is flowing, this output obtained is 0 because across the short path the voltage drop is 0. That's why this output will be 0. So we can say here for the positive cycle, no signal is obtained at the output. Now if we take the negative cycle, in negative cycle, the diode will be reverse biased. So if the diode will be reverse biased, it is taken as open circuit, and for the open circuit we have the circuit arrangement like this. This is the open circuit and we had given this is for negative cycle, we had given the input here and we can take the output across the open circuit. And in parallel connection or shunt connection, we have the output across the open circuit same as which is given at the input. So whatever the input which is given at the Vi, which is coming to the output. So output is equals to minus Vi and the waveform obtained here will be, this is the negative, positive cycle is clipped and negative cycle obtained here is this. So this is the V out obtained. So this is the circuit how we can going to analyze for the negative cycle. So in this case, since the positive cycle is clipped, this is called as positive clipper. Similarly, if we want to make the negative clipper, we can have to reverse the diode. For negative clipper, same arrangement will be there. Only the diode will be reversed. This arrangement will give us the negative clipper. So in this case, we'll obtain the signal, positive signal as it is, since in the positive cycle, this diode will be reverse bias, and for reverse bias, this circuit will be open. So we will get the output which is equals to plus Vi, same as I had told you in the negative positive clipper. And but for negative, as soon as we will take it for the negative cycle, this diode will be forward biased, and in forward bias, this diode will be acting as a short path, and for the short path, output voltage will be 0. And that's why negative cycle will be clipped off. This is called negative clipper, negative clipped off. So this is called as negative clipper. So this is the basic concept of parallel clipper. Now this is going to show the complete circuit, that are the possible combinations of series clipper. So in this we had studied this circuit. This is the basic circuit for the positive clipper and this is the basic circuit for the negative clipper. Now next is the bias series clipper, which I had explained you. This can be seen here for this arrangement for positive terminal battery and with negative diode connected, we will obtain the output like this. In the negative side, we can say here positive portion is clipped off, and with the same arrangement only the diode is reversed, we will get the output in the positive side, or we can say all the negative portions are clipped. Similarly, in the third case, we can see the battery is reversed, diode is taken in the same arrangement. In this case, we had obtained the output only in the negative side and positive cycle is clipped. Similarly, in the fourth case, only the battery is reversed, diode is in the same arrangement, we will get the whole positive part, only the small portion of negative cycle is clipped off. So these are the possible combinations that can we make with the biased clipper circuits. And similarly, it is similar for the parallel clipper also. As I told you, for the parallel clipper, we can make positive clipper with this arrangement and we can make negative clipper with this arrangement. And if we want to make the bias clipper as explained in the series clipper, we can also have 4 combinations in this. First, we have a combination biased, we are set to here by connecting a DC source. So in this, we are connecting the DC source in series with the diode. So by connecting this DC source, we can have different waveforms. In this arrangement, diode with positive P side above and with battery positive, we have this waveform. In this, positive cycle is clipped. And in the second case, we have batteries in the same direction, battery is changed and diode is reversed. We have this type of waveform obtained. In this, negative cycle is clipped. Same, only the negative cycle is clipped here, and in this case, positive cycle is clipped here. And with the third arrangement, we have diode in the same arrangement, but only the battery is reversed. We have all the signal which is appear in the negative side, and similar waveform is obtained for the fourth case, but only in the positive side. And we can say here negative portion is clipped. So with this arrangement, we have different networks or different combinations of clipper circuits that will going to give you the different combinations of waveform with different level of clippings. So whatever level of clipping which we want to obtain in any application, we can apply that network at any reference level. This bias level actually giving the reference level which is going to clip the signal at a particular value. So I hope this will give you some understanding about the basic concepts of the clipper circuit. So Jai Hind to all of you. Thank you for this.